Hi. All right. Today we are finally, hopefully. Wait, why is the website looking so bad? Anyway, we're gonna work on the programming language, the kast again. We did the AST, so it is the time to move to the other things. All right, we're still doing the rewrite from the OCaml version. Daniel Pancake, hello. All right, so we want to have some sort of the interpreter, I think. Something is what we want to have. All right, we're going to start by what are the things that I want to have? We will write the interpreter, right? We will write the interpreter. But in order to have the interpreter, we will also need to have a compiler. Because we're going to compile the code into the intermediate representation, our own custom intermediate representation that we are going to interpret later. Right? In order to compile, we are going to compile it into the intermediate representation. Yeah. And then in order to interpret stuff, we are going to have the some values. Is like we're going to calculate some values in the interpreter, right? I'm going to write what a value is over here. I'll just prepare some modules here that I will need. And values are also going to be typed, so we will have the types too. Which we'll call tie. Okay. Those are the things that we need to start working on all at the same time, I guess, right? So let's say that we have a value. A value would be something like this, right? We have let's say we have a boolean with a boolean inside, or we have like an integer with an integer inside, right? Something like this, string with string inside. Okay, this value is specifically a value that is available to the interpreter. If we're targeting something else, then it's going to be something else, I guess. I don't know. Yeah, so we're going to have these things. Let's have these three types to start with, why not? So similarly to that, we are going to have the type. So type would be boolean, integer, or a string, sure. Let's have that. Sure. The intermediate representation. What is that? So intermediate representation. When we parse the AST, we get as a result the tree, the syntax tree, where everything is treated as an expression, but after the compilation into the intermediate representation, there's going to be actually two things. There's going to be either an expression or there is going to be a pattern. So those are the two things that are that the intermediate representation consists of. Mostly we just care about the expressions, right? So an expression, one of the most important ones, is going to be an expression that is called an expression that is called like native, or I called it built-in, I guess. If we take a look at the standard library here, right, you can see over here, for example, that the int32 is a built-in int32, right? So this is the thing. This is how we know that this type is built into the interpreter, right? So we need to figure out what a built-in is. Yeah. Okay, integer representation, expression is going to be built in. Sure. Maybe I should call it an I want to rename it from being built in to being native. I don't know. There's not much difference, I guess. It just depends on the target. The natives and the interpreter are built-ins, right? So we have a native. Also, every single expression in the interpreter representation is going to have some data. So there's going to be expression node, I guess. Similarly to how I'm doing the similarly to how I did the AST. The AST could have some data associated with it. Pattern expression node. Let's see. We have some data associated with it. Data. If this is a native thing, then we want to know like what is the native thing, right? So the name of the thing that I'm trying to like query from the backend to know what the this is an expression which corresponds to the name, which should like evaluate to a string, right? Something like this, recursive data types. And also, since we are going to recursive stuff, we need to have a box here. Okay, let's do some comment here maybe. Name expression that should evaluate to a string. Sure. Mark ordered as bad misspelling. File. Set spell. Whatever. I guess I will just disable the spell, maybe. So this is the most important one, right? A native thing like this. When I have the pattern data, I guess patterns technically are not really, I'm going to add them later. For now, everything is going to be an expression, right? And this is going to be the only expression for now. Maybe. And by the way, if we talk about the values, one of the values is a type, which is a type, right? Like that. Import create type. Just use superstar here. Use type, use value, use that. Okay. Okay, so let's say that this is the only thing, right? Let's say that this is the only thing. What I want to do is we're going to have the compiler what is the compiler going to do? Compiler is a thing that, let's see, do I need some state in there? I guess I will. The compiler is going to be able to compile AST, which is the AST. Let's import the AST, I guess. Use kast AST. AST, I guess. So we have the AST, and we should return the the expression. So everything is going to be compiled into the expression, I guess. At some point we'll want it to be compiled into a pattern too. Not yet though. Yes. Expression. Add missing generic argument data. Yeah. So what is this data that we have associated with an expression? We will have a type information there, which means that the intermediate representation in the end is going to have type inference data, right? Let's just call it expression data that I want to have in the end. Public struct expression data. For now, I'm just going to have nothing there, right? Yeah. I'm just going to have nothing there. Okay, so in order to compile AST into the expression, we will need to match the AST into some things. Alright, we can have a span associated with it because we have the span here from the expression data, I guess, right? Let's span, which means that span needs to be imported. Okay. Let's say that I have a complex definition, right? Complex definition. Okay, syntax definition is definitely a to-do here. This is definitely a to-do. I don't care about this one yet. A simple token means that it's like an identifier or a literal. Let's say that I don't care about that either for now. If I just want to parse this one thing as a native expression, then the way it was working is that the definition has a name, right? So I need to figure out what does this name refer to, right? It can be both a user-defined thing or a built-in thing. right? Let's just handle the built-in things here, maybe. So let's see. Definition. Why am I making a programming language? Hello. Why not? Because it's fun, you know? Isn't it? Well, at least starting to do it is fun, because starting new projects is always fun, you know? Finishing projects, on the other hand, that requires time. What are you working on? Are you working on anything? Definition. Name. Okay, I'm going to strip prefix, which is a built-in macro. Okay. Which is a built-in macro. Because that's what we have in the standard syntax over here, right? I guess standard syntax, right? So some of these things, like for example, this is a built-in macro assign, right? So what? So yeah. I'm going to figure this here. He was at the army for a month, and before that on vacation for a month. He'll start working on new things when you get back. Oh, okay. Don't you have any old projects? You say you're going to start to working on new things, which means that there is nothing to finish. I have something to finish, the game that I'm making, but I'll work on it someday. You know, one day I will work on it. Built-in macro. If let some built-in macro name is this, then then I am going to say self like, where would I store them? Where would I store them? Let's see. You scrapped all of them. You're a new person now. Nice. I wish I saved some of my old projects. I was really young, you know. Most of them just literally went into the trash bin and then got deleted. I didn't save them anywhere. That would be nice to look at them, to look at my old code and see that it was not that bad compared to my current code, you know, or something. Let's see, what is a built-in macro anyway? Type of built-in macro is something like a function. Something like a function that takes the compiler and takes the values, which is going to be a tuple of ASTs. Okay. And it's going to return the expression. Is that right? think that is right. Okay, so can I say that over here, built-in macros is a hash set from a string into a built-in macro, right? Something like this. Hash set. Use std collections hash set. Compiler, new help built-in macros. Oh wait, there's a hash map that I wanted to have, not a hash set. Okay, let's just import this here. Hash map, new, and then I say map insert something something. I guess I can just have a static stir here, technically. So we're going to have the native. Native, I guess. And this is going to be like self native. I don't know. Macro native. Let's have something like that. So we'll have a thing, function macro native self values tuple ast returns the expression, right? This argument has type for a this, which causes map to have the type this for a mute. Yep. I mean, isn't that how it's isn't it supposed to work? Mismatch type expected collection. Found this. Is it because this should be explicitly casted? There you go. To the function pointer, I guess. Otherwise it uses the concrete function type. All right. So now, if we have a built-in macro name here, right, then I'm going to say that macro, so the macro itself is the self built-in macros, get for this built-in macro name, right? And then we are going to say something like expect built-in macro not found. This should be like technically, I will use the errors to do error. Okay, so this is a macro. Oh, macro is a keyword. Macro is a keyword in Rust, sure. We'll do this. Now since this is a macro, right, I'm just going to over here just return macro we called with self and values, right? And values are these things that we have. Okay, nice. Nice. Let's see what we should have in general. We'll have the let's have the other command in the CLI. We have parsect, and we will also have the REPL, right? We will have the REPL subcommand. So over here, it will be very similar to the REPL. How about we have a helper function which is going to be like run REPL. Handler is impl fn mut on a string, right? So we construct the rusty line. Let's return the IRE result. Is TTY. So over here, we say run REPL. Contents, which is a string, and then we do something with it, right? So what do we do in case of the AST? We just do this. Everything else, this loop, goes into the run REPL helper. Well, my language will target it game dev like Jai. Well, I want to make a game with it, yes. But as you can see, right now what I'm doing is I'm building a REPL. The language is going to be interpreted, but it's both interpreted and compiled, right? There's a lot of things in the language, so that I plan to have. Can I make them all? I don't really know. It's going to take a long time, probably. I had something that was working previously. I'm doing a rewrite technically right now from the OCaml version, in which I could compile hello world into JavaScript. So that, yeah, my original plan was that I compile the thing to JavaScript and then I can run it in the browser and I make a browser game, a small browser game for the beginning, to begin with. Then we add all other backends later, like the native backends. But we start with the interpreter. Handler. Yes. Handler is mutable. Let's handle this as mutable. Okay, nice. This function should return a result or option or accept a question mark. Of course. So this should return IRE result like this. Right. We do okay. And we do a question mark over here. Okay. So now that this has been extracted into a function, we can do a REPL. So this REPL is going to run the interpreter, right? This REPL is going to run the interpreter. So let's see. We're going to run the REPL. We're going to run the REPL. Where handler. Where handler. is going to do a very similar thing to here. Actually, I will construct the source. All right, I will construct the source. So I need to parse it into the AST, and then I need to very similarly to, I mean, actually it is all very, very similar. Maybe I can, I'm just going to copy paste it for now though. Here, okay. This is the source. We're going to parse the AST. And Durkan, hello. Yeah, my Linux is not activated because I'm broke. Let's see. So in order to interpret the thing that we have entered in the command line, we need to parse the AST. After I parse it into the AST, after that, we need to compile it and then interpret it. Basically, that is it. That is it. So we are going to construct the compiler. Compiler is compiler new, right? So we are going over here to say compiler dot compile AST. This is going to be the expression. The AST can be nothing, but if I guess we just say let some AST be AST, otherwise I just return okay. So this means that the line was empty, basically. Line empty input. Okay. So we parse the AST, we compile the AST, we evaluate the AST. That is it. So we will need to have the interpreter. It's going to be very similar to the compiler, which goal is to convert the expression into a value. So value is interpreter evaluate expression, right? Okay, so let's go to the interpreter. Struct interpreter. Like this, and we'll have a function evaluate. We evaluate an expression and we get a result, a value, right? Okay, so we're going to match here. No, yeah, we're going to basically match the expression. Since right now I have only done this one. Right, we have a name of a native something, which is a built-in, right? So the built-in things into the interpreter are going to be a couple things. Like the types, for example, are going to be built in, right? So let's see, built-in values, or I guess, yeah, let's just call them built-ins. Built-ins is going to be similarly a hash map from a string into a value, right? Hash map, let's import this, right? Built-ins is hash map new map insert. Okay, so let's say that since what I have done is I have introduced a boolean into 32 and a string. Let's do this. If we have a boolean, then it's going to be a type which is a boolean, right? Very simple, very simple. Boolean, int32 and string. String is string, int is int, bool is bool. So those are the three things. If we want to have something that is native, then we're going to say that we're going to like match self built-ins get for the name. Oh wait, but the name needs to be evaluated. Yeah. Name needs to be evaluated. So let's see. Name is self-evaluate name, of course, because this is an inner expression, right? And then we need to like convert it into string, right? So this must be a string. Expect string. Expect native name must be a string. I will say to do error, just like in the other place. Okay, so let's see. A value. We are going to have a method here, which is going to be called expect string, right? Yeah, we will have an expect string. Self, which is going to give me a result. Result string. Or I guess I just give back myself here, right? So I'm going to match self. If it is anything else, then I just return error self. Otherwise, if it is self string s, then I just return OKS, right? That should be simple. That okay. In the interpreter, map error underscore s error message s is not a string. Was it error fmt? Okay. Then we want to implement display for values. Consider unboxing. Yeah, sure. Let's consider the unboxing here. Value doesn't implement the display. Okay, sure. Sure. Let's implement std fmt display for value. Okay, we match self. If it's a boolean value, then we write f. I guess we just do value fmt. Value fmt f. If it's a string s, I will say that I write it with a debug. If it's a type, then type fmtf. Okay, so this means that for the type, I also need to implement std fmt display for type. Match self. It's a boolean, then write f boolean. If it's an int 32, write f32 string, write f string. Okay. What about over here? So we need to match if the built-in, if we have a built-in or not. If we don't have a built-in, then we will panic. Name. Native. Name. Not found. I don't know. Built-in, native. Not sure. Why am I using two different names for the same thing? Consider borrowing here. What do you mean? Expected, unknown, found a string. Yeah, because name is owned, I guess. So we do Esther here. Okay, a recursive call side function cannot return without recursing a loop. Oh yeah, sure. Yeah, because the expression can also be like a constant expression constant. A constant is something where the value is already known. Then we just return this value immediately. So this is another type of the expression constant value like that. When I compile and I see a simple token, I'm going to match token here. Okay. Main. Let's import the token here. Okay, so punctuation should be unreachable. Comment should be unreachable. These things, yeah. Comment, punctuation, or end of file should be unreachable. It should never be the thing. Then we have identifiers, strings, or numbers, right? Let's just do the strings for now. The string is going to be compiled into the expression constant, right? Where data is the original data, I guess, or I guess what was it? Anyway, expression constant value is value string, and the value of the string is the contents here, which means that this raw is something that I can ignore. Also, we will have the initialize method here in the expressions over here. You see how this is generic? We will start with expression where data is specifically just a span, so that we will initialize this data separately, because I'm going to be constructing the expressions in a bunch of places. And this is where I give it extra information, which currently only contains the span, but I will have the type information there. Self into expression data. It's just this, right? So I'm just going to do match self. If it's a constant value data, then we do expression constant value is this, data is... Wait, isn't the inner supposed to be already initialized though? I think the inner should be already initialized. That's how it was working, yeah. Data is expert data. Span is data. Let's just instead do data span here. And okay, expression native name data expression data span. All right, good enough. Good enough. Okay, if I try running right now, we just run REPL, right? That's what we do. Just run REPL. I say something like hello. This will say that it is not yet implemented in the compiler 22. Okay, compiler 22. I have a simple identifier. All right. Okay, but I think if I have something like hello world, this is already parsed because this is a string identifier, so this should be like evaluated into a string. Our REPL loop is going to be very simple. We have the value, right, and we are going to say print to the output what the value is, right? Colon what the value's type is. So value and value type, like this. You know, so value is going to have the method which is going to be called type. This is going to return type. So I'm going to here match self. If it's a boolean, then it is type boolean. If it is an int, then it is type int. If it is a string, then it is type string. If it is a type, then it is type, which means that this is a new thing, which is called type, right? Type is a type. Okay. Variant name ends with the enum's name. Warning, Clippy enum variant names. Allow Clippy enum variant names. That's totally fine here. Okay, so let's try again. If I have a REPL loop and I say hello, it will say that hello is a string. All right. So that's the easy part, though, right? That's the easy part. Okay, and then the next thing that I want to have is I want to have like native int32. This should compile. Built-in macro not found. Okay, yeah. This should compile into an int32, which is a type, basically, because that's what it is. Built-in macro not found. Built-in macro. Built-in macro name not found. Right? Format. Like that. Hello? Hello. Gardienka. Hi. Native. I built-in macro call not found. Wait, what? Oh, because it's a call? Oh, yeah, because because I called it built-in, right? Okay. Syntax built-in. Built-in. This is the one. I'm going to have the same thing. Built-in macro. Native name. All right. Let's see. Native I not yet implemented at 55. All right. I mean, it makes sense. I didn't implement shit. So there you go. This is the macro native. So this should give me an expression, a native expression. Where name is let's take a look at the syntax. We need to have the name here, right? Which means that our tuple, let's see, values single into single named, values into single named, into single named name, you know, map or unwrap. Let's see. Where should this be? In the tuple directly? Like over here somewhere? Can I have function into single named self result t. What do I get in case of an error? Just self, similarly to how I did it there. So basically, if self unnamed is not empty, then I return error self. If self named length is not 1, return error self. And then we do if, and over here I need a name, right? Name is stir if self named remove the name. I guess we're going to match remove name. If it was some value, then I just return OK value. If it is none, I return error self. What code editor is this? This is NeoVim, Neovite, Neovite. There you go. Content for the NeoVim. Hello. Okay, sure. Let's have that. Name is values into named name. Okay, let's just do something like unwrap or else. Panic. You do error. I will explain this later. Mismatch types, expected box expression. Yeah, so like this is the name expression, and then I need to compile it. So we need to do self compile AST, compile AST, and this is the AST that I want to compile. Exactly. And then we need to box it because it's a recursive thing. Sure, we do that. Unwrap or else. Unwrap or else, consider changing the closure to, oh yeah, because it has an error. Yeah, there you go. Nice. And then the data is going to be the data. Since so the data in this case, I need to have a span, right? I need to initialize this later, but the data is supposed to be the span. How do I get the span information? Because this macro, the native macro needs to know a span, I guess, of when the macro was called. So span is an extra argument here then. Right? So a built-in macro is something that also has a span. Like that. So data is the span. Okay. And then over here, the span is going to be span. Because this is the data is span, right? Let's call this data is span. Data is span. Okay. Let's see what happens then. Let's say that I have native hello. This will say built-in hello not found, which makes sense. But if I say native int32, then int32 is supposed to be found. Interpreter now, interpreter 2031 over here. So if I have found a built-in of a certain name, right, then the value is here. The value needs to be cloned and returned, right? So we just return the value, but like this needs to be cloned. Okay, so we treat every value as clonable, at least for now, right? Maybe we are going to panic inside the clone if I try to clone something that's not supposed to be cloned, but for now we just derive clone here, right? Which means that type also needs to derive clone. Okay, let's try again. Native string is a string type. Okay, there you go. There you go. This is not very useful though, obviously, right? Yet. Not very useful yet. What would be the first step that I would want to do here? Like if I want to make a calculator, for example, that would require me having numbers. In order to have numbers, I need to have a type ascription, which means that I guess, yeah, with type ascription, I guess it should be good enough. Let's try type ascription. So for example, if I say 1, 2, 3, this is going to be not yet implemented because the compiler does not know how to do the number over here, right? We have the number and we don't know what to do with it. We do not know what to do with it. But what I want to have here is I want to have an expression which is so number and number is going to specifically be a number expression. Did I have a number expression before? I guess that makes sense because I'm going to attach the type information to it later to figure out what exactly is the number it is. Let's see. Yeah, we had a number and a string. Yeah, sure. Let's have a number expression where the raw value is this, right? Data is span, and then we need to initialize that, right? Okay, number, expression. So here's a new expression, is a number. Raw string data, expression number, raw data span. It is expression number, raw is just raw data, is expression data with the span. Okay. Sure, so we know how to compile it. Then we will need to evaluate it here. We have a number. So here's the problem, right? How do we know what the number should be? Because, like, I mean, right now we can like say that all the numbers are integers to start with, but later we want to use the type information to know what the number it actually is here. Right? Can I start by having the types immediately without spending too much time on things? I don't know. Let's try. Let's try. Let's try. Data is. So here's our expression data, right? In addition to the span information that we want to have just for error reporting, the actual information that we need is the type that this expression evaluates to, right? So the type is a type, but the type might not be known, right? But the type might not be known. But anyway, in case of a constant, the type is pretty easy. Type is going to be just the type of the value. We know how to get a type here. If we have a number, then we are not going to initialize it with anything. So type is going to be a type. And for the things that we want to be inferred, this is going to be like the infer variable. The infer variable. Right? I don't know. Maybe I can start with having inference immediately. Inference is not that hard. Anyway, but for a native, the type is also going to be unknown. So infer is going to be a new like variant, right? Which is the inference variable. So which means that we will need to have inference module like that, and we will have the variable here. Okay, sure. Can I just have yo Veldek, hello. So, can I just do import variable public function new self, right? It's going to be enough for now. So inference variables need to be cloned. There's going to be some reference counted shit here probably. We'll see. Okay, type infer by Mac, so you don't have to activate Linux. But Mac, it's more expensive than Linux. I can just buy Linux then. So in case if it's an inference variable, we need to be able to let's have a to do here actually. Infer variable. I will do a to do here. So we need to be able to query the inference variable whether it's known or not yet. Mismatch type. So over here we have a number. What I'm going to do is I'm going to okay, and also I guess the type needs to do what? The type needs to do something. We'll need to import type. So like inference variable is something like very special, right? Because like it can be known later basically. So we will have a method which is like get, you know. This is going to mean like get actual value if it is an inference variable, right? And it might not be known, I guess, in which case ding, 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 ding. I can return an option self here, or like I can just return the inference variable as is if it's not inferred yet. That's what I was doing in the OCaml version. I'm not sure which one is better here. I can do a result. This self and inference variable. Maybe we call it get inferred, you know. So every type can be like not really inferred. Do I have like a separate enum then, like a type that is known? There's a type that is not known. I don't know. I'm going to keep it like this because that's how it was working before for me. A flat self infer variable is self, then we do one thing, otherwise we just return self, you know. In this case, so the inference variable should a variable be like variable of type t? Because I will have like inference values too. Can I make this a generic thing? You know. Let's have phantom data here for now. Phantom data b. What's the API that I won't have anyway? So I will have like a method which is going to be called like get inferred. I don't know. This is just a variable. I'm just going to have the get, and this will give me the option t, like whether it's inferred yet or not, right? And that's it. There's going to be functions to like make two variables the same and other things. Today's daily run had really good start. Ambrosia potion, another ambrosia on first level as well. A lot of health plus and chest on the first levels. Then you died. Nice. On the third level. Lol. Oh, it's Saturday. I was about to ask for. Yeah, makes sense. It's Saturday. You can play a game. No need to do the work, right? It's just I am sometimes myself lost in the days of the week. There is advantages and disadvantages at not having to work. Let's see over here. So what are we going to do is we have a number, right? We have number, so data type, get data type dot inferred, right? We're going to match data type inferred. If it is error, then we're going to panic to do error. Number type could not be inferred or something like that, you know. Then if we have an okay, what game am I playing? Veldek is playing Noita. So if it is an inferred type, which is an int32, in this case, I will return a value, which is an int32 of raw parse expect to do error failed to parse a number, right? Like that. If it is an okay and then any other type, then I will say panic to do error other is not a number. Inference variable of type. Inference variable of type. If it is an inference variable, then I'm going to do variable get. Get okay or var, I guess. That is it. Mismatched types. Type infer, yeah, so like type infer is a variable, so we need to do inference variable new here. When I'm initializing, I don't know about the variable yet, basically. Okay, so now if I try to say 1, 2, 3, this is going to say not yet implemented inference. Not yet implemented over here, right? Because I'm trying to get this. If I just return none here, then it will say instead that number type could not be inferred, right? So let's see. Maybe we can have the inference immediately. Let's see. Inference is kind of relatively simple, I think, right? What we need to do is we need to get. We also need to set self with the value of type t. We also need to do that. Right? Wait, do I ever need to set? I mean, I guess sometimes I need to set, right? Yeah. And also another thing that I need to do is I need to have a function make same. So this variable and another variable must be like the same, right? So this is important. We're going to store this now. We're going to have a pointer to the root variable, right? Let's see. State is just arc state t, I guess. This is going to be struct state. Let's call it var state maybe or something. So this is going to be arc arc modex. Sure, why not? Let's import arc and let's import mutex. So the state is going to be basically it's either is a root or it is or this is not a root. You know, I mean it's basically like an enum. You know, it's either is a root, in which case we have the value of type t, which is optional if it's already been inferred or not, or if it's not a root. Not root. So in this case we have something. Let's have this named. Why not? In case it's not root, then something that's closer to root is another arc modex self, I guess, like that. So when I'm initializing myself, I don't need phantom data anymore. Instead, we say that state is arc modex var state root, where value is none. You know, we just do this. Okay, sure. Sure. So when I have the get, I need to do something like, wait, I cannot give it a reference then directly, right? I guess I cannot return a reference here, but shouldn't I be able to, if this is a variable that is inferred, would I store this in an arc too, like the value itself? Or maybe the value should be like clonable? No, I guess an arc should work here. In which case I return from the get the arc t instead of t. Because this value itself is behind a mutex. Alright, sure, let's try that. Let's try that. So we do self get root. Self get root dot value dot clone, I guess. That's all I really need to do, right? So get root is a private method here, which will give me so the get root will return an arc mutex or state itself. I guess, which means that after getting the root, I'm going to lock it and then clone the value out of it. Because this is the root, right? Or state the function as root self so this would be I guess it's just panic here in case it's not and arc the like maybe even without the reference then we just don't clone, we clone over here. This is supposed to be unreachable here. Um, oh, this is not mutex self, this is mutex of our state t. Can I do this without the arc mutexes? I don't know. Maybe. Anyway, so over here I'm going to I guess we do this. We get root on the self state. Get root self is going to return that. Okay, so I'm going to match self state, but then I need to lock it again, right? Match self. Anyway, so if it is already a root in this case, we just return self cloned. Wait, can I make the arc mutex get root? I don't think I can make this a receiver, right? Arc mutex self. Invalid self parameter. Yeah, this is invalid, which means that I need to call this not self but this instead. We are matching this. There we go. Match this lock wrap. Again, this is defined here. Wait, what? Can it move out of the reference? Yeah, I mean, I meant to do this. So okay. So I guess we just do then var state get root using self state like this. Okay. Getting the root means that if we have the closer to root something, right? Then we will say that root is closer to root dot get root of get root of the thing that is closer to root, you know, I will return this root, but I will also say that closer to root is equal to the root so that I update it for later. Which means that this needs to be cloned here, but it's an arc. Sure. If we want to set, then variable state get root self state lock unwrap so like there's two things, either it already exists or not, right? Here when I'm doing this set, so if it's none, then I just say that as the root should arc t. Should I have the as a root here by using the mutable self, which will give me the access to this so that I can like do something with it if I want. I'm just going to take the thing out of there. If it was none, then I'm going to say that root is some value, otherwise some previous value, right? Root is mutable option arc t. This needs to be inside an arc. Okay. If we had some previous value, then I need to like make sure that they are the same, you know? I need to make sure that they're the same. Okay. So we're going to do t make same previous value and the new value. Okay. So t is like the thing that we store inside the inference as must be like in something that is inferable. In order for something to be inferable, I need to be able to know if two things are the same. You know, which also this depends on clone, I guess. And we have the make same a self, b self, something like that. So over here also I am just replacing root with the make same. Right? That new value is root is some new value. And arc, I guess, is going to be over here. Something like that. Arguments to this function are incorrect. Expected t found this t. Of course, I mean I just want to that. Consider the change in this to be mutable. Sure. Consider using let to create a longer lived lifetime. Yes, of course. Need to do that too. Consider changing this to be mutable. Wait, I just literally did. Okay, and now we say that trait type is not something that can be inferred. So type we need to implement inference inferable for the type, right? Which means that I need this to be public. Right? Okay, so I'm going to match A and B. Okay, that's a little bit too much. But yeah, if we have a boolean, then it is a boolean. We have a boolean and something else, and we say panic. Let's return. Yeah, sure, let's just panic here. I don't know, fail. Macro rules. Fail. Panic. I mean, it's not inference failure. We expected one thing, inference. I guess this calls type checking. Failed. Check error. Something. We will rename. We will do something else later. If it is an int and an int, then it's an int. Otherwise, we fail. If it's a string and a string, and it is string. Here we fail. If it's a type and a type, then it's a type. Otherwise, type and anything else is going to fail. If we have so like then we have this inference variable, which is a little bit special, right? Yeah, so like technically what we want is we want to check not A and B, We want more like I'll get returns this too. Result self. I guess I just clone these things actually, you know? Result app. Map value clone. Can I do this? Like that. Okay, self clone. That's a lot of clones, but okay. So I'm going to just match A inferred and B inferred, right? So basically, if it is OK A and OK B, if they are both inferred, then I need to once again match A and B, like I was doing, you know. Otherwise, if A was but B was not inferred, in this case I say that B is same B. I need to basically set the value of B to be equal to A if A was not inferred but B was inferred, and then we say A set B, right? And if they are both not inferred, they're both not inferred, then I say that A makes same as B, right? And then we need to make sure what I returned here. What do I return? Let's just return A. I clone it again here and I return A. A set B clone B. A make same B. And then I just say that we return infer A. Non-exhaustive, yeah. So like over here, we should say that type and infer on any of these should be unreachable. Right, okay. Let's see, we have something. It's not going to work though, right? 1, 2, 3. Error number type could not be inferred. Number type could not be inferred. I mean, that actually like is exactly what it's supposed to be. Hi. Hello, Olivier. Hello, Colhis. What we need now is to make sure that I say something like 123 int 32, right? Which means that I need the type ascribe macro to be defined. So let's go to the compiler and type ascribing to work. Let's see. Macro type ascribe. Type ascribe. With an underscore, yeah. Type ascribe. Macro type ascribe. So if I have a type ascription, std syntax is defined somewhere here. It's value colon colon type. Just start working on the money programming language using kast, and I realized I'm not smart enough. What do you mean? Money programming language? Monkey. Oh, okay. What do you want your language to do? Or did you are you saying that you're not able to figure out how to use the AST here, the library? Or do you not know? Monkey programming language is an existing language, is it? Monkey programming language. Monkey lang. Monkey is a programming language that you can build yourself by reading through the writing interpreting Go. There is no official implementation of Monkey. Like a proof of concept language for compiler courses. Okay. It has functions. Integers are arithmetic expressions and strings, booleans, arrays, and hash maps. Is this just like a classic Python language, basically? Or a JavaScript, I guess, with a slightly different syntax. That's what it looks like. I don't know. I feel like JavaScript should be pretty easy to implement. I mean, you don't care about performance, right? Much. A value type. Compiler. Type ascribe. So if we have the thing that is type ascribed, right? Then what we will have? What we will have is let's see, values dot get. Well, I need more methods on the tuples, I guess. We have add named, unnamed, named, iterators. Right. Can I have? Wait. So how about this? Instead of into single named, how about we do something like this? Function into named, where we will have the const n is going to be a use size, because we can do that in Rust now, right? We have self, and the names is going to be this static array of strings of size n. You know, we can do that, and this will be a result of tn self, right? So very, very similar what I have here, but different, right? So if named length is not equal to n, and we return error. Otherwise, we say that if names if any of those not self-named contains key name, and we also return error. Otherwise, we will start unwrapping ourselves. We will return OK. We we will return okay. Names, map, name, self-named, remove, name, wrap, since the checks has already been done. How did I split? That was an accident. Okay. And then into single named is basically like, let, I don't know. Let's see. Self into named, name, map, value, right? And that is it. That's nice. Okay. I'm not really using unnamed tuples yet. Okay, so over here, I will say that let steady syntax once again. I expect to have a value and a type, right? I expect to have a value and a type. So I say that let value and type to be equal to values into named value and type, right? Unwrap or else panic to do. So I have the value and I have the type, right? What we need to do over here. So this is where we need to do some comp time immediately already, right? So interpreter should be a part of the compiler. Is that what it? Yeah, I think so. Did I just have a global, like, I did not have a separate struct for compiler versus interpreter, I guess. So yeah, we have the value and the type. The value is an expression, right? So we are going to compile AST, which is the value. You know, we're going to compile that, and we are going. So that's our value, which is compiled AST. I'm going to return that, but we need to say that value data, I guess data mute, because I'm going to mutate it. So whatever this value is, I need to set its type, which means that if we go here, I need to have simple t expression t function data mut self mut t. I'm gonna call it data, right? Match self. I mean, not even match. We just say let data to be self. Then we return data. Like that, I guess. Wrap the pattern in parentheses. Sure. There you go. Is never used. Okay, there you go. Data mut mut dot type. So the type, this type, needs to be made the same as the thing. Why did I make it to be the type instead of it being the type inference variable? I mean, it's the same thing, I guess. Right? Do we just do inf inferable make same. So this type and the actual type, right? Make same as the type. Okay, let's just have the method here. Public function make same mut self and make same as the other type, right? This is just going to say that self is inference inferable make same self and other. Do I just clone self here then? So many clones. I guess it's okay. Alright, but the type is obviously not an AST, right? So I need to convert the AST into the type, which means that I need to evaluate this. This is where the comp time needs to happen. Which means that I need to evaluate this thing. So we're going to have, in addition to compiler and AST, we're going to have the eval AST, which is going to be evaluated into a value immediately, right? So we're going to say that expression is self-compile AST, right? And then we do, and then we need our own like interpreter here, right? I mean, compiler is the interpreter, kinda. So do I even make these to be? I think I just literally say then. Finally using Rust. Yeah. It has been happening for like a week already. But I was pretty slow at rewriting the AST parser. So I only am just starting the language basically. Like I have the AST, but nothing nothing after that. So I'm literally like going to work on all the things at the same time. I will have the compiler, the inference engine, the interpreter. All of the things here at the same time. So the problem is that the compiler is the interpreter, right? So so like it's not even like a separate thing, you know? It's literally is the same. Do I just call it kast instead? You know? Let's instead have over here built-in macros. And then we have public type built-in macros is this. Built-in macros returns the built-in macros. Is that right? So I don't implement the compiler, I implement the kast. There we go. That makes sense, right? I'm just going to have a public just going to have a struct kast, which is going to have like I guess we have like some compiler state, and we will have some interpreter, which is like the interpreter state. maybe kast function new self compiler state new, and interpreter is interpreter state new, something like that. So compiler, yeah, instead of doing this, we're going to have struct state, and this is going to be the built-in macros, like that, right? Impl state function new self built-in macros is that stuff. I guess. I don't know. We do that. Let's say do the same for the interpreter. This is struct state, implement state new, and over here we say implement kast. So kast can evaluate an expression, right? Or it can also evaluate AST, which has the AST, and it converts it into value, which means that in order to convert the AST into the value, we will need to have it convert into expression first. So we will compile it first, compile the AST first, and then we evaluate the expression, right? I mean, it's simple, yeah, like that. So now we call compiler from the interpreter and interpret from the compiler. And then over here I say that type is self evaluate AST of the type, right? And also when I evaluate, this a value, right? This value must be a type, right? So we do something like as into type, unwrap, or else value panic do error value is not a type, something like that, right? So into type needs to be made on a value. So type is this is the type of this value, and then we have into type, because a value can be a type itself. This would be a result, a type, and self. So I'm going to match. Yeah, I mean, I guess we just match self. If it is self type, then I would return okay type. If it is anything else, then we just return error self, right? Into type. So this is get the type of this value, and this is get this value as a type. This value, this value as a type. You know, it's a little bit different, these things. Okay. Would not do compiler, interpreter. So instead of doing compiler, interpreter, we just say that let mood kast is kast new, right? And then over here we say something like let value is kast evaluate the AST, right? We can even like parse, like this parsing can also be done there, I guess. Let's go. REPL. So if I say 1, 2, 3, it will say that the number could not be inferred. If I say 1, 2, 3, hello, then it will say that type ascribe is not found. Hold on. Why is type ascribe not found? Compiler. Because I have a typo. Okay, amazing. How can I make sure that I don't have a typo? Is there a concat hold on, concat literals into static? No. Rust concat identifiers in std. This is a nightly only still. This okay, sure. Well, I guess what I can do is let's do this. Macro rules, impl, whatever. So what I want to say here, I want to say impl. This is a keyword. Let's do populate. Populate. Let's do over here populate. Populate macro native and macro type ascribe. How about that? So what I will do here is so this is going to be like names, right? Which is identifier. We split it with this, and then we have optionally another comma in the end. So what we want to do here is we want for every single identifier we do map insert. We'll map insert. We stringify the name, but then I strip prefix of the macro underscore, and I unwrap. And then I say cast colon name as underscore, and that's what I want to insert. Okay, I think this should be good. No rules expect the token macro native. Wait, what? Because I forgot $1 here. There you go. Okay, so now this should like take care of me. I should not be able to have a typo, right? So if I say 1, 2, 3 is as a hello, right? This is going to say that hello is not a type, right? So I should not be able to type ascribe something with a string, right? Hello is not a type. That makes sense. So we need to say instead, which needs to say instead that 1, 2, 3 is int32, but int32 is obviously not implemented right now, because it's an identifier that is not bound to a value yet. So I should instead say something like int 1, 2, 3 is a native int32, right? There you go. Now we know that it's this. So now I need to be able to now I need to like also be able to bind the this expression to a constant. We can just say that 1, 2, 3 is int32, right? Yeah, something. So what we want to be able to say is, I guess I need to do a let. So let int32 is native int32. That should work, right? Still the let macro is not found. Compiler. So before doing this as a macro, let's do the intermediate representation, the let. Right, the let is something. So this is where the patterns are going to appear, right? So we need to have so we have value, which is an expression. We have pattern, which is a pattern. And we are going to do these things, and this should be like boxed and everything, right? Yeah. Okay. So we have expressions, and we will also have the patterns now. In pattern also will have the data, which is going to be pattern data, which I think should be like the same, but we will make it separate for now. I don't know. I don't remember. Did I store anything different from the like pattern data versus so this has inference data and state. Why did I have state here? No idea. Maybe it's like was capturing the state or something. Pattern data. Pattern data was just the type inference. Okay. I also was never like storing the span though. Now I will store the span and the type. So the pattern should be, for now we just will support the identifiers patterns, right? Or like we call it a binding. A binding. A binding where do we just do a name here? Let's just do a name for now. Let's have a name as something like more unique, like in case we have multiple names that are the same. So I should be able to refer to these things separately. So we'll have a struct name, which will have like the raw, like it says as the string and the ID or something. Something like this is what I want. For my IDs. So I have name. Name would also be phone, partial, egg, hash, bug, maybe something like that. So we have a binding to a name, sure. There is even fartlang. Oh, should I even Google this up? Fart is an application programming language that's easy to learn, easy to scale, and deployable everywhere. Why does this look as an actual thing? Open in fart pad. Is this just literally Dart, but the thing is replaced with F? This like fart pad. This link goes to the Dart pad. Like Dart. I mean, I never saw it. I mean, I saw a little bit of Dart a long time ago. Watch the videos of the Fart Developer Summit. Is this automated to be in sync with the who uses fart? Join the fart team. Okay. All right. Let's see. So over here, we say that so this is the initialization. Initialization is a thing. Like initialize expression data, which initializes the type inference basically. So if we have a let pattern value and data is span, then we need this to be a let expression where pattern is pattern, value is value, but the data over here is going to be expression data where span is that. But what is the type? The type of the let expression is just nothing, right? The unit type. I was calling it void before. Should I call this a unit type instead? I'm not sure. I liked my void. What do you think? So in something like C, if a function returns nothing, then they say that function returns a void, right? But technically, if you are like in Rust, it's called unit, for example, right? There is I don't know. I just don't like the name unit for some reason. In Kotlin, they have the unit. In Swift, the unit is called void, though, for example. But I guess most of the languages call this a unit when we have nothing or an empty tuple. I don't know. Let's make it a unit this time. I don't know. Type unit. Unit type unit. Type unit. Only after the inference, this over here is a little bit special. Type unit and anything else should not type check. Okay. Over here, type unit. We write f unit. Should it be unit or should it be like an empty like this then? Like, is that the same? That's how it works in Rust. Sure, let's copy Rust for now. Expression let data. Non-exhaustive patterns let not covered in the interpreter. Okay, so if in the interpreter, if I see something like a let binding, a let expression, right? Then what I will do is value is self-evaluate the value, right? What I will return is the value unit, which means that I need to have this unit. Then I need to have a to-do here, which is assigning to a pattern, right? What's the name of the language? The name is kast. Hello. We have a small website. You can take a look there if you're interested. I'm not really doing this from scratch right now. I am rewriting this from the previous implementation in OCaml into Rust. So I kind of know what I'm doing a little bit here. At least until a certain point. What do I want? I'll consider unboxing. Yeah, sure. Haskell not mentioned. Well, Haskell never got anywhere, so... Oh yeah, I wanted to have the unit, this thing here, right? Yeah. Self unit is right after that. That's the unit. Value unit is type unit, right? Okay. All right. Am I doing this for fun or to make the next big thing? Well, both, but the making it the next big thing requires a lot of work. So for now, it's for fun. But I do have a but that's a big if. If I can get the thing done, then it can be the next big thing, right? There's a lot of interest, I think. Even if I can do something like this, then I can find people that would be interested, because I start reading more and more like blogs recently about people like wanting something similar. The recent one was rewriting Rust. No, this is a response. Rewriting Rust over here. This one is a post from a couple days ago. What the hell is this background? Like, they literally want the fantasy language, that when they want to have the function traits and everything, like people start talking about the function effects, but like every week I see someone talking about wanting this now. So I think like a new mainstream, a new language is going to appear at some point, which is going to have these things that we want with like comp time and shit. But with other features than comp time, so like not zig, you know. But yeah, so yeah, I guess like the big features of the programming language are the function traits and the comp time. I'm literally starting by having the interpreter here with a REPL, because comp time means that the compiler is the interpreter. So yeah, I mean, I have already a little bit of the comp time technically, right? So when I say something like 1, 2, 3 is native int32, like this is what I have implemented so far. This is going to be evaluated at compile time when I'm, so like the way interpreter works right now, I'm compiling this into the intermediate representation expression, right? But this intermediate representation has the type information. This is the type ascription. So in order to know this type is going to be evaluated at compile time. This in this case is a very simple thing, but it can be like a more complex compile time expression, I guess. The IDE that I'm using is the Helix. Oh, not the Helix, Neovide. Sorry. Yeah, it's a front end for the NeoVim. Okay, what was I doing? There was like a to-do somewhere. I mean, there is to-dos in a bunch of places, but the one that I want about is this, right? So we want to implement the let pattern be value, right? For that, we can evaluate the value, and after evaluating the value, we're going to do the pattern match, right? We're going to do the pattern match. Which means that pattern dot do match is going to be, or I mean, I guess we just call it match. We pattern match on a value. There you go. We just do this literally, the pattern match. Let's see here. Implement pattern. Implement pattern function match. Self with a value, right? What should this return? This should return for every like name, I guess, for every binding. What is its new value, right? So we will return a hash map from name into a value. There you go. And this can also fail, but for now, for failing, I'm just panicking. Let's do a must use on this function too. You're going to go study Zeke's comp time. You don't know what it is? It's very simple. It's just running code at compile time, like, you know, C++ const expression or like things like that. In Rust, we have also the const functions, const function foo, right? It's just in Rust, it's very limited. You know, in Zig, you can do like pretty much everywhere. Like in Rust, you, in order to do anything, you need to create a procedural macro. Then you can run any Rust code. Otherwise, it's like, yeah, it's like annoying to use in Rust compared to Zig. It's literally just the interpreter for the code that you have written already. Okay, so let's see. If we have a pattern and a value, right now I only have like a single pattern, which is the binding with a name, right? So in this case, I'm just going to return. But people use it for build a Zig. Build Zig is build Zig just means that they have the, that's not about the comp time. It's just in Zig the build system is part of the standard library. It's independent features. I want to have something like that too. It's just like you don't need cargo, I guess. You just have in standard library the thing that like allows you to specify what your project is. So instead of writing this toml file, you just write a little bit of code to specify what your project is. Kind of, you know. I guess it's more of a replacement for like a make file. I'm not sure like how dependencies for the dependencies they had like the zig zone, right? The zig zone stuff. I'm not sure if it's like on top or still part of the standard library. But yeah, it's separate. Imsurial, hello. dy. What do you mean dy? You mean yo? All right, yo. What's up? Self match impl result. Atmut result is I just call it impl. Impl self value result. result is hash map new. I return result in the end, and then function match simple. Pattern is pattern, value is value, and matches is mutable hash map. Name into value. So I'm going to match pattern. If it's pattern binding, then we say that matches insert name value. That's it. So like if this is the only thing that we cannot even fail technically, right? We just do this. Match. Yeah, this needs to be like a reference, which means that name over here is going to be cloned. But yeah, and then over here I need to use it. So this is the thing. One time I first writing my language in Haskell. No, I was first writing it in OCaml. Then I tried a little bit to do it in Haskell. But Haskell sucks, so I'm doing it in Rust now. Yeah. OCaml, I was writing OCaml just because I was learning OCaml. I originally didn't even want to make a language. It just was my project to try and learn OCaml, and then it grew a little bit. But OCaml became too annoying, so I wanted to rewrite it. And so I'm writing it to Rust because Rust is my go-to language. I'm writing Rust for a long time. That's why I stopped with OCaml. I mean, I could continue with OCaml. OCaml, I guess, technically, I thought that Haskell would be much better, but it's just too annoying to use. Fortunately, OCaml was okay, but yeah, like compared to Rust, it still is annoying in my opinion. There is I really miss things like traits and shit. Not that I really need them. I can do a lot of work without them. But there are other annoying things in OCaml. You really like OCaml? What's my take on Dark? Anybody used it? I did not use it. I did not look into it. So yeah, I don't really know. I mean, OCaml is okay. OCaml is okay. If I did not know Rust, I would even say that that OCaml is a pretty good language. If I did not know Rust, you know. Okay, so here's what we're going to do. This is the thing, and we're going to introduce the new things. For me, it's because you know Rust, you love OCaml. I don't know. There's a lot of annoying things there, like the module system and the absence of the traits, especially if you know Rust. Don't you miss the traits in OCaml? The module system is pretty bad, I think. I mean, it's okay. It allows you to do the same things, but I want a combination of both the module system and the trait. I think traits are better. They're like, I don't know. You like functional programming? Yeah, I also like functional programming, which is why I thought that I would really like Haskell. And Haskell, I mean, I do like Haskell, but the problem with Haskell is that it's just unusable because of its small issues with like the fact that the records are done. I don't know. It's just like annoying. Like the type system and everything. I like in Haskell a lot. but it's unusable. The language server is bad. OCaml also has a pretty bad language server. But I mean, compared to Haskell, OCaml's language server is like amazing. The module system is not that bad. I'm writing a highly recursive program here. I have a compiler, which is at the same time an interpreter. Everything is very recursive, which means that I need to use the recursive modules in OCaml, or write everything in a single module. If I write everything in a single module, I need to write the recursive function definitions in a single block, recursive types in another block. I cannot mix and match function. I don't know. It's a lot of small annoyances like this. The type inference based on the field name is really bad, I think. Really annoying. I add in a thing, I need to fix it everywhere. I mean, it's not like breaking at runtime, so I guess it's better than a lot of other things, like dynamically typed languages, but I don't know. There is a lot of small annoyances that I found in OCaml. I was there is like this module T pattern OCaml, right? 6 pattern. Like, what do you call it? What do you call it? Not module T. Pattern in OCaml. Why can I not find it? There's a thing. There's convention. Convention to use T. No, T is about the type T. Or maybe that's what it was. I don't know. Anyway, I don't know. Like you start with a module, then you realize that you need to make it a functor. Then you realize you need to make something recursive. It's all very... I don't know. Like it works nice for simple programs, I guess. But so does Rust. Let matches be this. We shouldn't forget though, Rust was written in OCaml. Yes, and guess what? Rust was rewritten from OCaml into Rust. You know why? Because Rust is better than OCaml. Otherwise, they would never rewrite it from OCaml, right? It's pretty obvious, right? Okay, so the interpreter state is going to be the values, which is going to be a hash map from a name into values, right? We start with values being an empty thing. Remove return. Ensure matches is this. We do self values, self interpreter values extend using the matches. It's just called bootstrapping. It's logically do this at some point, otherwise you will spend all the time programming the compiler language instead of your own language. Yeah, no, I was just joking. If you like OCaml, that's good for you. But I mean, it's mostly preference. Well, I prefer better tools. All right. Oh, I like some things about OCaml. I don't know. My brain works too much with the traits, I guess. Better is a matter of opinion. I don't know. Would you say that OCaml is better tool than like assembly? Like, why do you not write in assembly directly? Or like we can compare it with dynamically typed languages, because I think this is pretty objective, that if you write some complex software, then writing it in a statically typed language compared with dynamically typed language is going to be much easier, because you're going to be able to not write a lot of stupid things. That's my definition of better. It makes it easier to... I don't know, like, the better means like easier to make progress, I guess. Because that's what makes most sense, right? I guess some people would say that OCaml is better because it doesn't have the borrow checker, and you can just, and it's just a garbage collected language, so it's much easier to use because of that. Like, there are some things that make it easier, like you can have recursive closures and shit that you cannot do in Rust, really. It's annoying to write in Rust. But, yeah. Like, Rust could be better, but I think once you get used to the borrow checker, it's okay. I think in the long run it's better than the garbage collected thing anyway. So we just have the values that are extended like this, I guess. And then we also need to be able to have one more expression, which is down. They try and solve two completely different problems. I don't know. I think they don't. I think Rust covers more problems that can be solved than OCaml, because Rust is both low level and high level, and OCaml cannot do some low level stuff. So Rust covers more areas. So what I want to have another expression here, which is going to be like a binding, right? What did I call it before? How do you call this expression? We just tries to get a value with a name. I guess we just call it binding, right? Binding name. I mean, there is a lot of people who disagree with me that Rust can be productive. There is a lot of people who have rage quitted Rust after using it for multiple years. Because they think that something like Zig makes them more productive. I think that's not true, though. But maybe it's just me and my brain, which doesn't work with other languages anymore. Last time I tried doing some simple shit in Python, I couldn't do anything because I was so annoyed at the language. So maybe it's just maybe I'm just, I don't know. Once you go Rust, it's over. Yeah. Well, I mean, it's not over, right? Because I'm literally writing a language because I'm dissatisfied with Rust, right? Rust is no longer good. I hate Rust. That's why I'm making my own language here. Because there is a lot of problems with Rust. You 100% wouldn't say that Rust is productive? I don't know. There's a lot of people who say that because, like, I don't know. They fight the borrow checker and other things. I mean, there is some valuable feedback. I guess the recent post that I remember was from the log games. This one, right? leaving Rust game development, right? They like made a couple games in Rust and then they... No, they did not leave for Zig. They left for Unity, I think, right? They did some game like this, and then they stopped using Rust. What were the points again? Context objects are not flexible enough. Dynamic borrow check-in causes unexpected crashes after refactoring. Yes, of course, don't use dynamic checking. Global state is annoying and inconvenient for the wrong reasons. Games are single-threaded. Ah? Rust game dev assistant lives on Hive. I can kind of agree with that. Hello, Mr. Too Few Tests in chat. Hello, Dev Ninja. Rust is productive, otherwise all those big companies wouldn't use it, lol. Well, I guess like the like I don't know. I'm in the camp that thinks that Rust is the most productive language, but yeah. Okay, so over here, since I am accessing the binding of this name, then the type of the expression that gets the value of the binding is the same as, like, we can know it immediately. So we will say expression, no, we will say binding dot type here in the span, which means that I need to have the binding. That's why I had the binding struct before. Binding. This means that expression binding needs to not only have a name, we need to have a binding, right? And the binding is a combination of something, right? Let's see. Struct binding. It will have a name, and it will have a type. Right? What am I trying to solve with my language? Not solve, but add and change. We have a website, but I can talk through it a little bit, I guess. One of the things that we want to have is the comp time. So that it's easier to do something like in Zig. If you tried Zig's comp time is a good example of what we want. And another thing that is pretty big is the function context, which is basically the algebraic effect system kind of, which makes it easy to pass allocators around and like control other things. I actually learned recently that Jai language has a thing that is called context stacks. Jai context stacks. The way to Jai book. Is this the book of Jai? A central concept is Jai is concept. Let's see what it is. File not found. Amazing. Jai community stack trace. Jai style context for allocators, etc. Yeah, where is like, okay, so this is the issue for Zig, which does that. Jai uses a context which contains things like default allocators. I want to like understand what it is. Or is this the same as in Odin language, where they have like only a single context type? You should really ask John Blow to give you Jai. I don't know. I can just read about it. Is there like, or can I not read about it if I don't? Can I not read about it if I don't ask for it? Is there no documentation online? Learning Jai for Advent of Code. I think it's the same as in Odin, judging from like these small things. The context contained a few things: default memory allocators, temporary allocator, logging functions, and style, which is probably same as the Odin context. Jai context on the D language forum. Implicit context. Yeah, there is a implicit context system in the Odin. But yeah. Context, the missing feature of programming languages. Let's take a look at this. What is that? It's an article on Medium. If I had the opportunity to define my own eponymous law, it would be this: an ongoing software will eventually become Rube Goldberg machines. You want light or dark? Die deadlocks. Where's the important part? Die deadlock. Context. We often talk about functions like platonic ideals, white cubes floating in endless void, taking inputs and producing outputs. Okay. This is how do we define function: a list of arguments, an output types, and a name. If our simple endless was accurate. Too many words. Much as we like our platonic ideals, our pure functions, we ultimately have to acknowledge that every function exists in a context. Okay, I think this article is about exactly the feature that we have. So basically, when you are writing functions, they must exist in a context, right? And this is basically an implicit thing in basically every programming language. If you try something like Haskell, you have the monads, which allow you to like have your contexts as types, right? And everything. It's kind of similar. But your functions are still pure. We take a different approach. In object-oriented functions, you can also have functions in a context. I think that means different though. Thing. Or link context. Context is only genderless because it's absent from functions arguments and is so opaque to the color. The idea of moving away from implicit context and working toward explicit context is a good start. What do they come up with eventually here? In programming language jargon, an effect is anything that a function does beyond just returning a value. There you go. So yeah, so like the feature is usually called effects. Modifying state, printing to the console, making a network call is an effect, right? Knowing when a function modifies states is half the battle. The other half is knowing when a function reads state. Like read is also... Read is... This is not an effect, but rather a co-effect, although sometimes it all gets lumped together after the banner are effect or effect systems. Examples of research languages that have explored different approaches to effect include F, Effect, Flix, and Coca. Exception handling is context. One interesting insight I got from the research is that exception handling is basically a special case of context. A thrown exception propagates up the call stack until it finds a catch block. Yeah. Effect TS has something like that. Like what? I mean, yeah, it's called effect TS for a reason, because it's having the effect system. Which is, I mean, I'm just calling it context, but I think it's basically all the same thing, kind of. context system, effect system, capabilities, like implicit arguments even, are kind of similar. It's basically my type func is effect, return error requirements. Yeah. I don't know how to explain it if you don't know this concept though first. But yeah, it's basically like when you call a function, you need to know that a function that like you want to know what a function can do, and you want to assert that a function has the ability to do the things that it wants to do, right? Like if the function wants to write to a log file, or I mean, if a function wants to log something, it needs access to a logger. If it wants to have an access to the database needs to be the function needs to have access to a database. So like you can do this as a function argument, or you can do it as a context system, which is basically like implicit arguments, but kind of a little bit different, you know. So yeah, there's a lot of things that can be done with that. How long ago is this article from? This also, no, this is from 2023. All right, but still, it's kind of like relatively new. This idea. I mean, in OCaml, since you like OCaml, they do have the effect system in OCaml. Did you try using that? OCaml effects. They have that too. But like, because OCaml, like you don't have to use this, and it's a little weird. Because of that, it's like a language within a language, basically, if you try to use something like that, similarly to how the effect TS, the thing, you know, this is like when it's implemented as a library, like you need to stay within the boundaries of the library to use it properly. It's pretty new though, OCaml. Yeah, I mean, relatively new. It introduced 5.0, which is what, like, isn't it like at least a year old? I don't know, when was OCaml 5.0 release? It's in 2022, so it's like 2 years, more than 2.5 years old already. But yeah, I guess like in general, this idea is relatively new because it's just a couple years old. Like the like right now, a lot of people are doing this active research, trying to do this in their languages. So yeah, so far I think the best introduction to the effects is the Coca language. Even if you don't try it, you can read the documentation here to see what this means, right? So if you have a function that yields, then it's like what Rust is right now trying to do. They try to make functions that are sometimes async, sometimes not async, right? And without writing the function twice. So you want to be generic over whether the function is async or not async, and like other things. This is what effects allow you to do, basically. It's just like a basic building block for things similar. I compare them to monads, if you know what a monad is, but I try not to talk about monads because they're scary, right? I think context, calling it a context, like, is kind of easier to understand for people, but I need to make some effort trying to actually write something. Did I write much about the context system? Like, here's an example, right? If you want a function that does allocator, that does allocation, you need to have allocator in your context. You're more scared of comonads. So like, yeah, you basically like annotate your functions with the things that they need, right? So the allocator, like if in something like Zig, would be passed as an argument to the function. But instead of it being as an argument, you make it basically an implicit argument. which must be in scope when you call the function, right? And you introduce it into the scope with something else. Like, because it's an implicit argument, you can use it with some things like operators easily, right? And everything. And it's not very verbose by having like 100 arguments to your function. And it's not, and it's supposed to be implemented differently than passing arguments. Like when you compile to C, you don't actually pass these implicit arguments as arguments. They are stored in a different place and accessed differently. I'm not sure if there's a paper about that, but I heard the term that is called evidence vectors in the effect system. Is that it? Generalized evidence passing for effect handlers? This paper, maybe? I'm not sure. I didn't read this paper, but I think this is about how you can store these things efficiently. I mean, this is also about the resumptions, so yeah, monadic translation. Maybe I will read it one day. Binding has a type and a name. That's what a binding is. Binding, and I guess binding over here, we will have also instead of a name, we'll have binding, which is arc binding then. So we can clone it easily. Arc import. Expression binding also will contain the arced binding. A comonad. I don't think I had to deal with comonads. I remember reading about them briefly. Comonads. I remember this person from somewhere. It just does a bunch of category theory and Haskell. The analog of the fish operator for the Coke-Lacely arrows is defined as this. Just so that you guys know. I don't know. I think I'm gonna stick to the turbofish in Rust for now. Exhaustive patterns. Okay, so this is the evaluation. If I want to evaluate a binding, then all I need to do is I want to do self interpreter values get for the binding name expect binding not found. Okay, let's do this for now. And I need to clone it too, I guess. This effect stuff is pretty strange. Maybe you need to really understand it. I think you know, if you like, it depends on what you're trying to read, because I think if you're trying to read the OCaml effects, then I think the introduction on the OCaml effect over here is not really like easy to understand, I think. Like, it's almost like assumes that you know what it is before you use it. You know? Similarly to a lot of other things. So if you're interested, I really suggest to do the Coca language. Just read about it a little bit. But yeah, like, it's... Yeah, in Java you have checked exceptions as another alternative. Like, if a function can throw a certain exception, that would be in the type signature. Kind of similar thing, yeah. But it's just more general than just throwing exceptions. Okay, so, and also, since let's take a look over in the over here, initialize the data. When I have the let expression, I have the pattern, and I know that the type of the pattern must be equal to the type of the value, right? So here's what we're going to say when we initialize this thing. We're going to say that pattern dot data type data type make same as value data type, something like that, right? What's the best way to start using Vim? Do I also know a good setup guide? Why do you want to use Vim as is the question. What do you currently use? If you maybe if I may, I can suggest using the Helix editor instead, because it has the good defaults and you don't need to configure it really. It basically is similar to Vim. If you don't use Vim yet, just use Helix, I think. I mean, if you really want to use Vim though, then there's just a lot of ways to do so. And I don't know. I personally liked the I don't remember the tutorial, because like I learned Vim kind of a long time ago. I used it a little bit, then I came back to the NeoVim. But the base setup that I used was called nvchad. So nvchad is a thing that can set up, is like a thing that you can convert to your own custom NeoVim setup kind of easily compared to other things. Or you can just start from scratch and like, I'm not sure what is better. Maybe if you never used Vim, actually this is bad, and you should just try using the raw Vim. I just don't think raw Vim is good experience. So I don't know. I don't know how to do it as a beginner. Like, there is the Vim tutorial that is built into Vim, but I don't know. I think it's not enough. Vim tutor, yeah, it's there, but like you just start Vim and you do colon Vim tutor. Oh, what is it? Tutor, like this, right? Welcome to the NeoVim tutorial, and then you just read through it. It tells you how to do things. I don't know. Start with an IDE with Vim extension for motion first. I don't know. When I tried it, I went just straight into Vim, and we used it without any extensions. We had a very, very small configuration, but I wouldn't say it was a good experience. I don't know. Like, it's like working in a notepad. Writing code in a notepad is not very nice. You know? Like, you need the features of the editor. Like, you need to set up the language server and other things. OMG keeps ignoring. Why you ignore me? Why do we don't own the best programming language yet? Not yet, Brainoid. Hello. If you're not familiar with motions, it's hard. Yeah, you can try using an extension. When I tried an extension, I didn't like it though. Like, I'd rather personally go directly Vim. I don't know. Like I said, I think it's just the Helix is a better thing to start. Like like there are things that are missing in Helix, but they're going to come there at some point, like the extension system and stuff. Maybe Cocoon, actually. Any of you tried Cocoon? I didn't try it. Do they have the users can extend the features and customize to like with macros or hooks? Like, is there a plugin system there? Plugins. There is plugins. Okay. See, this is what is missing. Or is this all? Is this all the entire list of plugins? Okay, maybe Cocoon is, I don't know. Have your plugin shown in that list? Or maybe it's only showing some of them. Anyway, I don't know. I would just stick to VS Code. Like, there is no reason to learn Vim, actually. No reason. I just use Vim because I like this Neovide. I like the animated cursor, and in my VS Code, the animated cursor is not as good. Also, NeoVim is like this animation is smoother than what I have in VS Code because VS Code is bloated, I guess. But in terms of just if you just need to write code, VS Code works better. This is something to get started. Kickstart NeoVim, yeah. I didn't like Kickstart NeoVim. I don't remember though, or maybe like it was too small when I was setting up my thing. Like I said, I started with NVChad. It was relatively easy to understand. I guess Kickstart is like smaller, right? I mean, it still is like multiple files, so like you need to read through and shit. They are pretty small though. Yeah. I think I tried Kickstart, but then I don't remember what I didn't like about it. Not enough things in it, maybe. Remember that Discord GIF from Kuviboy with an insane explosion ice case that appears to be Nuke? I know why it's not spherical though. Vim NeoVim, when you panic and press Ctrl C, there are instructions to quit Vim Helix when you panic and press Ctrl C. Let's comment this line of code. Wait, I literally bound the Ctrl C to commenting in, like, I literally rebound most of my bindings to match the Helix in Vim because I like them. Like selecting the thing through the two-seater with Alt O and Alt I. If only I had the multi-cursor, that's what was working. I need to try this multi-cursor NeoVim plugin that was recently released. Maybe it's good enough. Okay, anyway. We have patterns. And I need to have impl pattern data. Helix is already at a certain stage with plugin system. Yeah, I think they ended up wanting to have some Lisp-like language, right? And then, yeah, Lisp-like language, yeah, like this. For some reason, I think this is going to make it less, like, I don't know, like Lua kind of, I mean, Lua sucks, so this is maybe better, but I'm not sure if it is. I didn't really look much at what this actually is. Is this also a dynamically typed thing? Because then, why? Really? What is the language that they use? Add Steel as an optional plugin system. Steel. Did they make their own language or? Pure Rust plugins. As part of this, I spent some time trying to expose a CABI from Helix to do Rust. To Rust plugins directly in Helix without the scripting engine with little success. Still supports loading dynamic libraries over a stable ABI. Use this to develop the proof of concept terminal emulator. So you might not be a huge fan of the scheme. It's the scheme, right? But in theory, you can write mostly Rust and use Steel as glue if you'd like. I don't know. It just makes it harder to do plugins. No. Steel is a choice of our language. I understand that there is skepticism around something like Steel. However, I have not been working diligently on. I have been working diligently on improving it. My current projects include shoring out the documentation and working on LSP. Wait, so it's literally their own language that they made, a scheme. Steel is a scheme, which is a Lisp. Developing a custom language implementation. Yeah. I don't know. Compile your Helix every time you want to configure. Yeah. I don't know, like they will make their own language and then there will be like the same as what happens to Vim. There will be like the Neo Helix, which will use Lua instead or something. I mean, making a language is fun, so they're going to have some fun at least. Okay, I wanted to have the method function data mut self mut data match self. No, let self binding data self data. Mut pattern mut value. Okay. So this means that the type of the pattern is going to be equal to the type of the value that I'm pattern matching against, right? Okay, good. What else? Then I'm never constructing this thing. I'm never constructing this thing. So we need to have the yeah. So like in order to be able to write in code, let x be hello. Right? In order to do this, we need to implement the let macro. So we'll go into the compiler, the built-in macro, macro let, I guess. So we have over here macro let like this. Mm -hmm. Yesterday you died to not knowing it's a bad idea to use Luma to create air pockets in a water tube because they can be an invisible connection between pockets and the one filled, and today discovered why people are so scared of mobs with explosive boxes. One, you just get the kinetic damage from them flying. Oh, really? I never died to them like that. Okay, so we're gonna have a let. The let is going to be compiled into the let expression where we have the span. We also will have the binding. No, not binding, pattern. So pattern would be, let's see, let pattern and value to be values into named pattern and value. Unwrap or else. Heck. So we have pattern, so we will need to be able to compile into a pattern, right? So like I said, we have expressions and we have patterns now, right? So we need to compile compile self.compile compile, maybe compile AST needs to be compile expression instead, you know, and we will also have compile pattern, which is very similar. We just, instead of convert the AST into the pattern, right? So we compile pattern, the pattern, and that's my pattern, and then value is self compile expression value, and that's it. I need to box it. Compile expression. Okay, so compile pattern is also going to be pretty similar to compile expression, I guess. All right. It's going to be very similar. Very similar. A string, a number, pattern matching against numbers. Yeah, so we can have a pattern to be a constant, I guess, right? Yeah, I never supported patterns being constants in the old implementation. Let's just have a to-do for now here, though. To-do. To-do, comment, punctuation, and a file unreachable. Okay. So now we have built-in macros once again, and we have built-in macros which are expression macros. Built-in expression macros, and we will very similarly have built-in pattern macros. So those that are inside, that are like doing the pattern. Yes. Macro expression native macro expression describe expression. Or we can do it without. Hold on. Or I can do it like I did it previously. So the way I was doing it previously is that we still have just built-in macros, but built-in macro is something that can that can compile into like compiled thing, where compiled thing is either an expression or a pattern. So those are the two things. And when we want to like do something built in like this, we are going to tell it if we want to have like the type compiled type. Yes. Compiled type. So what do we want? An expression or a pattern? Like this. So when we say macro native type, like this is more wait, can I have a const? Can we have a simple things like this? As a const things. Oh yeah, I guess what I can do is I can do a struct expression macro, and I can have struct pattern macro, and we can have a trait macro type, right? Something output. So I would like implement exploration macro for would implement macro type for expression macro, where output would be expression, right? So this way, like I could make this generic. No, hold on. Which one is better? So basically, a lot of the syntax is going to, maybe it's not a lot, but like some syntax looks the same in the like works basically the same in a pattern position versus an expression position, right? Like type ascription, for example, I can do type ascription in patterns, but that should return not an expression but a pattern. But it's going to like work the same way, which means that I would need to copy paste the thing. Or I could make this to be checked at runtime and have this return either an expression or something based on some runtime flag. That's how it worked before. I'm not sure if it was but like I would still need to do this code basically literally the same. Over here I would compile a pattern instead of compiling an expression, right? And this part would be exactly the same. And yeah. I don't really want to copy paste, right? So what I had before is like you know how we right now have the function compile pattern and compile expression. We had basically a function compile, which would say like this AST needs to be compiled into what, you know? But can we have it like be based on trait system or not? Is new language gonna be ready for LD? If I did not do the rewriting into Rust, then it could have been, but I don't think it will be. So maybe for the next LD. Or am I succumbing to DAW with Bad Cop? I don't know. If Bad Cop doesn't want to overscope, then maybe. Or maybe I'll just do my own small thing. I'm not sure yet. Maybe I'll just join someone and draw some paint art instead of coding. You know, I also think this might be a possibility. If someone else makes a game and I just record some fart noises in the microphone, that would be like, you know, do that instead. Can I do something like this? Compile T. This would return T, where T is something that is compilable. You miss Scooby solo MMO things? Yeah, maybe I like do something like that. There is, we'll see. We'll see about the theme, and yeah, I don't think I will form a team before the theme is revealed. I will see if someone wants to join after the jam starts. If I want to join someone, probably. How many days is it until the Ludum there? Like 10 days or something, right? 1 week. 6 days. Oh shit. Last time I checked this, it was 10 days. The days are flying. Okay. Did you see the post that said like anything but the anything but folklore? Yeah. Did you slaughter folklore? Pomo, thank you. Cast speedrun. I mean, we can make something simple work, but like I can make a bunch of like we can make this as an embeddable scripted language, right? So we can use both Rust and kast at the same time. So we like use it for scripting some small things. Could do that, maybe. T compile south ASD. Maybe we can do this. Rate compilable. Rate compilable. Function compile. Kast. Kast. ASD itself. Like that. Something. You'll use Kast as your main language and Rust for some small scripting. Imagine having not just stream avatars, but some server that people would be able to connect and control your character or something via an API. Yeah, maybe once Kast is ready, we are going to redo the overlay so that these crabs are going to be replaced with unicorns, and you could do some more with it. That would be like a good project, you know, because like making a Twitch bot is relatively simple, right? Making an overlay like that, it's not a full game, so it would be a good example project. When people use Rust bindings for Godot, that's basically backwards. So can I do this? Can I do this? Can I do that? Impl compilable for expression function compile. Kast is this. So I'm literally going to do this. We're not going to have even a function compile expression then, right? Or I mean, we will say something like self-compile. St directly, we just delegate to that thing. And then we go here. It's just instead of self. I now need this to be kast. I guess. Is there a GD extension for Rust? I don't know what that means. I know that you can write Rust in Godot. I don't know how it works. What is a GD extension? But anyway, when I say built-in macro, this should be a built-in macro that compiles into specifically the T. So the built-in macro is a generic type for T, I think. Can I do something like this? So built-in macros, built-in expression macros specifically, would be a built-in macro expression, right? And built-in, like, because I cannot store a generic thing, built-in pattern macros is this, but for the pattern. And then over here, I would say something like let mode expression. This is expression. And we will also have a pattern. This is the name. Let's name be that. So we do this, kast name, and we do the turbofish here for the expression, right? So these are going to be like generic. And pattern, insert this, but for the pattern. There's a popular GD extension for C++ which lets you write Godot nodes in C++. Rust bindings and the GD extension to use Rust are one and the same thing. Okay. Built-in pattern macros. Pattern. All right. Let's see now. Let's see now. Remove these generics. So this macro native. This should be T, which is compilable, right? I don't think it's going to work. Like, how to make this generic? For example, native stuff. Like over here, I need to assert like this should only work for expressions technically. Right? So this means that I would need to like create another struct, which like is the macro native, which like does things. I think this is not going to work. Unless we will have a combination of both. What if I have still compiled I did do this, right? Yes, we'll have the compiled and compiled type is expression or pattern. Criticans, hello. So maybe built-in macro is not going to be generic then after all. So it's going to give me the compiled stuff, which is going to like make sure this is just built-in macros. Again, going back. Built-in macro on primitive cast. Yeah, this longer needs to be here. Are you AI? Yeah, let's see here. Well, I mean, in this case, like, I do need this to have, in addition, the type, compiled type, right? Like that. Fine. I mean, it works for a camel version, so that's... I know that I can do it this way. Compiled. So I'm going to assert, in this case, assert that type as... the type is expression, because native can only be an expression, and then I will say compiled expression is what we get as a result, right? Like this, which means that that thing needs to be like derived. Partial copy, clone, debug, partial, hash, sure. Let's derive all of these things. Okay, macro let. Like, let can also be only an expression, right? Let also can be only an expression, so I did this. Type, compiled type. Compiled. We return compiled expression, like this. But for the type description, for example, this should work with both patterns and the expressions. So we will say this is the value and type. Type is that. Value is compile expression. Value is not compile expression. This is going to be compile. Well, I guess compile is going to compile a type like this. So this is not going to be generic. T-compilable. Public function compile into type out type compiled, I guess. Can I do this? Can I do this? So I'm going to match type, and this would be self-compile. I mean, we just do compiled expression, self-compile, AST. So we have the AST also. This would be compiled pattern, self-compile. Yeah. So we have a combination of like the static and dynamic thing. So, and then over here somewhere also we'll have implement compilable for pattern. I will just move this thing here. This would be self-compile ASD. Okay, so over here, a value that I'm prescribing is going to be compiled into this type, right? And then I'm going to so like all of these have the type, right? Type but make same type. How about that? Arguments to these are incorrect. Yeah, because I want this to be let's call this CTY. It's a good name, right? CTY. Ample compiled function type mod self into mod type match self expression e data mod type pattern p mod p data mod. Okay. BB. Okay. So let's see, when I'm compiling an expression, I will have the built-in macros, right? The macro is something that returns a compiled thing, so I need to call this, since I am compiling an expression, right? I need to compile type expression, since I'm doing this. Can I just do something like typed macro like this? How about this? Impl typed no, not impl, function typed, or can I do something like compilable macro? How about that? So compilable can compile, and we will also have a function macro, which takes macro, which is a built-in macro. And this will be impl function kast st into self. This. Oh, I cannot name this thing in the impl-fn. I can only do this, like, this is very weird also in Rust. Like, when I have a function pointer type, I can specify the names of the arguments, but when I do the impl-fn trait, I cannot. Annoying. I really like having the names. And we also have values, which is tuple of, yeah, we have the tuple of ASD, I guess. And we have a span. right? So we're going to move cast values and span. We're going to call the function with cast and then self cty, I guess. Values span. There you go. And then function cty is I guess not function, self cty. Const cty is compiled type this. Const cty is compiled type expression. So we do this, consider the reference in the borrow. I mean, because it's a reference to the macro. Okay, all right, and then we need to match, and then do like self from compiled this. Yeah, there you go, there you go. So function from compiled is compiled into self. So function from compiled match compiled expression E term E pattern P pattern unreachable, I guess. In this case, we do the other way. Expression is unreachable, but this is the pattern P, and const this is compiled type pattern. Type annotations needed cannot infer the type. What do you mean? The macro is this. This should return self. This should return self, right? Oh, it's because this should be just like self. Yes. And I am borrowing the thing. This is just a function pointer, I can just reference it, which means that this does not need to have a reference. Yo, Nerdzel. How are you doing? Are you ready for the Ludum there? It's in 6 days. And this is also copy-pasted code. Okay. I mean, this is like the only one, though. File is no more private. Expression, macro type. You're less sure that you will participate. And A4. Let's see here. Let S be high. Not yet implemented at 91 of the compiler. Over here. Okay, so we have we are trying to compile a pattern, which is a simple identifier. And what needs to happen here is that I don't care about the raw. All I care about is the name here, right? So we are going to have a pattern binding, right? Pattern binding. This is going to be a new binding. Where name is name new name. right? And ID, Helen. Name already has the ID, right? Yeah, we have the type. That's what we want. Yeah, and binding should be like arc binding. Arc binding. Arc. Type. Type. So like by default, we don't know what the type of the binding is, so we initialize it to the infer variable, inference variable. New. Okay. Fail to resolve. Use our undeclared import arc. Sure. Name. Simple name. Public function new. Name impl as impl into string, I guess. No, not into string. Or is into string. Self name into ID new. Raw. There's a chance you will get support for developing one of your games, so you're busy with that. All right, that's nice. Data is going to be span. Then we initialize the pattern, right? Okay, so similarly to initializing the expression, we want to initialize the pattern, impl pattern n, public function initialize self into pattern. So if we have a binding where data is span, return pattern binding, where data is pattern data, where pattern data, where span is this, type is equal to the binding type, right? Clone, I guess. And binding is binding. Let A is okay. Hold on. A not yet implemented. Compiler 45. Compiler 45. It looks like the let actually worked or something, but let's just see if like it actually assigned a variable or not. Hold on. Yeah. So like over here, similarly, the identifier when it's compiled into an expression and as opposed to being a pattern, in this case, it's going to be very similar. I don't care about these things, right? Oh, but I need to know which one is in scope, so I bind it to the same one. Okay. Hello, Picorli. So this would be expression binding. So I need bindings. I need bindings by names. Bindings by names because like binding, there can be like multiple bindings with the same name, but we want to find the one with the name, you know? Yeah, we want to do that indeed. Data is going to be a span, and then we initialize that. Wait, what? Possible harasser? Oh, it's not the first time. Wait, or does it not show if it's the first time? Picorli. I thought you created an account in like 2 seconds after Nerdsel said Picorli. Binding. Okay, so I need to find the binding by the name, which means that in my current state of the compiler, I need to know about the bindings that are in scope, you know? Yeah, we need to do that. Compiler state. We have interpreter state and we have compiler state. But compiler is the interpreter. Also. The interpreter state, we have like the values, which are a hash map from name into value. I mean, we just need strings anyway, do we? Not? Why is this not a string? This should be just a string, I think. Hello, Jorly. Is reply done via tags? I don't know. It's just there in the library that we use. I don't work with the raw protocol of the IRC. There's a library that we use. Which just has a method reply to, and then it does all the thing like automatically. Values. Like, what is the why did I make a name like this? Why? Why did I make a name like this? Well, I mean, there should be like, in terms of like the compiler, when I'm compiling the let expression, okay. Okay, when I'm compiling an expression, all right, it's a little bit weird now. So yeah, basically what needs to happen is that when we introduce a like when I'm in the process of compiling stuff, right? Like we know that the expression I guess it doesn't really matter yet. I guess it doesn't really matter yet. Wait, how should this work in the interpreter? Wait a second. Actually, if you replace myself with yourself, the translation figures it out. Um, I don't know. Let's have like maybe something like local names. Local names. And it's going to be a hash map from string into a name. Maybe I'll do something like this. Local names hash map to finding. So I need to find the local name here. Or I guess it's like isn't it the bindings that I need to find a specific binding? I think so, right? Yeah, because like then we know that the type is the same as the type of the binding. Yeah, yeah. Local. Let's just call it locals. From string into a binding. Into an arg binding. Binding is going to be self kast. Compiler locals. That name. Expect Name not found. Clone? Sure, let's try that. Is this built on C++? No, it says Rust. Hello there, one Dabster. In just a second, we will be able to see how this all works. But I need to like introduce the local, right? Because it's not going to be found. You know, like if I say something like A, right? It's just not going to say that A is not found, right? Because it doesn't know what A is, right? But it still is going to say this, even if I say let A be A, right? So like it's supposedly evaluated successfully, and if I call A, it will say that it is not found. So the question is, how should we do that? It's more like in the let, you know, macro let compiled. So like technically a compiled thing is going to be like Mhm. um how is kast better than Rust? Um well, because it's more powerful. It allows you to do more things. It's not better yet, though. It's just an imaginary language right now. Explain on the website, Kappa? Yeah. It kind of is explained, but it's not explained very well, I guess. It could improve the website. And to review it, maybe like rewrite it all from scratch, do a second edition. So, my main loop looks like this. We just evaluate, right? When I evaluate, I will put the thing into the list of things. Ease of maintenance instead of focusing on speed of running on ice cream, no go for me. Well, maybe go is for you then. Although I don't know. Like, are you saying that all you're doing is prototyping all the time? I think prototyping is overrated. Anyway. There's no way all you do is prototype. Most of the time you are supposed to write software that is not a prototype, no? Everything is a prototype. Well, yeah, I mean, so like, that's what I'm saying, like, everything is a prototype, which means that eventually your prototype will need to be maintained anyway, which means that it is not a prototype. Which means nothing is a prototype. So, like, there is no reason to focus on prototyping speed, because it doesn't matter. What am I trying to do here? I don't know. How about I just say something like for name and matches dot keys. I just say name raw and like self compiler Hello Ray March. Compiler locals insert name raw name clone something to do something else. All right, I'm just not going to think about it yet. Prototyping means how things start. There would be no Twitch, Rust, and Noida if we were not moving from ASM to C for faster development. Yes, because it is faster to maintain code in C, and not because it's faster to prototype in C. Yes. Prototype in Rust and rewrite it in kast. Yeah, exactly. Um, I just and also like I'm saying that I'm not focusing on the speed of prototyping, but like it's just like I don't know, like some people have a weird understanding of what is the speed of prototyping. Like some people think that that a dynamically typed language allows you to prototype faster, and I strongly disagree with that. Like even although you don't need to write your types, it's just not true. It doesn't speed you up. It slows you down, in fact, by not having this feature. But yeah. Do you allow that? I don't know. I mean, I think there is nothing wrong with it. Let's stop being automoted, yeah. I mean, if you say this in Russian, that's totally normal, I guess. I'm not sure if like I don't know, nothing wrong with it. I think it just means weirdos, I guess, by that. Um. The return type of this call is name due to the something. Mismatched types expected. No method raw. Wait, what? This is completely a different thing. Public function raw. Self. Self raw. And over here. The return type of this call. Mismatch types arc, binding. Oh yeah. I need a binding here, right? Oh shit, this needs to be a binding. Hold on, matches must be matched to a binding, not to names, right? Yeah. Matches needs to be... So pattern matching should match not from name to a value, but it's almost like it should give me just a list. It should give me a list, a vec of a binding together with a value. That's what pattern match should do. Vivan do. Hello there. Thank you for the raid. We have Veldak coming from the raid. Are you guys did you guys do Noita or Factoria? I made that mistake in a C++ project. I thought C++ gives me more control, and therefore we started project in C++ in 2018. A competitor worked in a similar project in Rust, and obviously they were faster, even though we maybe had more control over memory. Did they have some heap fragmentation? Probably. They just got the thing done. Wait, what? Did they have some heap fragmentation? Probably. They got the thing done. They... Okay. For a moment, I thought, did they have some seg faults? Probably, but they got the thing done. You know, like some people really... some people, like, say those things. And at least I heard more people saying things like that. We have seg faults? Yeah, it's okay, but we at least get the things done. Unlike those Rust guys, you know? We had the seg faults. Okay. Get a raid and run because of the sleep deprivation. We did some Factoria and then some FTL. Nice. I never played FTL, by the way, still. Is that a good game? Should I try it sometime? I think I should not, because there is too many things to do. There is Factoria 2.0 coming, and that's going to eat each time, probably. Wait, you thought you had more control in C++ versus in Rust? What is this control that you're talking about, though? What is the more control? Doesn't Rust... What is there in C++ that allows you to have more control than in Rust? Or are you saying the absence of the borrow checker is more control? Or at least, like, that's what you thought. Allocators and sub-allocators, yeah, okay. I mean, technically you can do that in Rust, it's just like you need to not use the standard library, I guess. No? It's very difficult in Rust. Yeah, I mean, I agree. But it's not impossible. But yeah, I guess in C++ it's just easier. Rust has harsher requirements when it comes to object constructors. I give Kuvi 2 days to beat the game and 2 weeks to declare it easy. The FTL. No method keys. Okay, so this is now the for binding value in matches, binding name raw. We just put the binding there, and then we say that the values extend matches. extend matches into iterator map binding name value. Is that it? Smash types result hash map back arc binding value. So instead of inserting, we just do the push a new binding, which is this binding and this value. Okay, nice. In C++, you believed you was able to write your own slightly faster shared pointer compared to the standard library. In Rust, I don't think my skills are sufficient. Then again, who knows, maybe your shared pointer was full of undefined behavior. I mean, as far as I understand, the C++ standard library shared pointer might have undefined behavior. Okay, there we go. We can have a let a be hello, and then I say a, right? So if I say something like let int32 is a native thing, which is int32, right? And int32 is the type of the int32, right? And then we can say something like 123 is int32, and it will be like 123 of type int, and then we can we can also say something like let x colon int32 is equal to 456, and it will say that x is now 456, right? Okay, because if I don't specify the type, then it's supposed to just say that that the number type could not be inferred, but it could be inferred over here. Okay, nice. Okay, so technically this works for now, but it's not correct yet for all the things. But I think I have done progress, and I have not been committing today at all. Git diff stat. I just did 100 lines, or did I commit anything before? All I did is 100 lines, and we already have some things. All right, something works. People hate UB and not proven code, but hype over hallucinating and lying. And N. What? Neural networks. You hate the line neural networks as well. Yeah. That's why I'm not using AI to help me programming, because I hate it. Hate AI. I mean, it depends on what you're making sometimes. I mean, what you're making, like if you're aware that something can lie to you, it's like working with humans. You know, humans also lie. Humans also are wrong all the time, and you work with them still, right? But eventually you want to come up with something that's proven, right? You don't work with the humans.
Hi, do you have any plans to write your own operating system and ecosystem for it?
I plan to write an operating system and an ecosystem for it? No. I think I will not go that far. I think a custom programming language and a custom game engine is enough. Thank you for the donation. That was the first one ever on this channel. The other day I tried. Please stop donating? What do you mean? The other day I tried one of the new ones and it answered to one of the questions. I don't know, and that's such an improvement. Because they at least don't have to read a paragraph before coming. Because you don't have to read before coming to that conclusion. Because they're not making things up at least now. Nice. You know, because I don't have a donation bar. Eh. Okay. Let's do something simple. Let's do something simple and then so far what do we support? We support these things. We support variables, constants, which are strings or numbers. We support native things. The only native things are types right now, though, and that's it. That's all we support. I've been using the Brave Search AI, getting better at interpreting what it says. Sometimes it's pretty silly. Isn't Brave malware? Wasn't Brave supposed to be the opposite of the malware, where it's like it's protecting you from the something? Brave browser. It's like the browser that supports on privacy, that's like built on privacy or not? Or is that a different one? Brave. Fast, private, and secure web browser. I mean, it doesn't really tell me anything. I have no idea how browsers differ these days. They're all the same. It's super fast, is it? If you ever meet John Blow, what will you say to him? Hey, have you seen the Jai review from Soldier Boy? Is there a Jai review from Soldier Boy? Have you tried Jai, Raymarch? Jai Soldier Boy. Will Soldier Boy review the language? Soldier Boy already gave his grand take on Braid. Is that some famous person that I don't know about? It's a huge meme. If you know, you know. He's a quirky guy, but his games do not deserve that much time to make. Who's John Blows? Games don't deserve that much time to make. How long did it take to make Braid? Braid, not brain, Braid. J Blow. 3-year project. Making the witness. I don't know. How long do you guys think the link cider is going to take? I need to continue working on it so that it doesn't take as long. If the game comes out, it doesn't really matter how long they took to make it. Guess then double it. It depends on if I work on this project or on the game actually. Linkcider is not getting released. No, it is definitely getting released. You guys should wishlist the game. We have the Steam page. Is there where is the wishlist for your sandbox build? What do you mean? Alright, anyway, I think I'm gonna end for today. I'm a little tired. Progress is okay, I guess. With that music, the game must be fun. This is just the trailer music. There's going to be more music. Music is by Vess, yeah. There we go, guys. Wishlist the game. That's the other project that I'm working on. The programming language and this game. Alright. Did we add squash and stretch? Yes. Did you not see it in the trailer? Yeah. There is a little bit of that. Alright. Accept the cookies. Or is the green thing on their avatars on the left? On which avatars? On what left? You like the previous version in game music? The green thing? I don't know. It's a new thing. Knock to ask to collaborate. Like you as a streamer can ask to collaborate with other streamers.
Publish a game from our country.
Well, I mean, you like, well, you need to do something. You don't publish from outside the country, I guess. I mean, publishing itself is not that hard. It's just like you cannot pay for like in order to publish a game, you need to give $100 to the Steam to create a Steam page, and paying to Steam is the problem. Once you have paid using some friends or like by having a bank account in a different country, it's not really a problem. To me, the main selling point of Jai is metaprogramming and the ultra-fast compile times. If it still is as fast as it was when he showed it, that's a huge selling point. One how powerful of graphic construction one can write with the reflection info. Yeah, I'm wondering. We're going to have that in cast 2, you know. But we're going like I don't know what are the features of other features of Jai other than meta programming. But I don't know. Did you try the D language, for example? Because D language also has like these things where you can like iterate over the fields and shit. Meta programming was pretty strong in the D language too. Or like I wonder what are the other features of like if is there like a plan for Jai to have a website or like a public build or something like that? Or is it going to be forever an invite-only language?
And then I'm like,
Alright, anyway. Let's go to TCAP for some C++. I'm going to end the stream.
what's happening here? Rine failed. Oh yeah. Bam.
It's kind of hard, like what I did today. We're working on like the compiler, the interpreter, all like the type inference, even a little bit was done all at the same time. Compared to what I did in OCaml, we just like were interpreting the AST directly without compiling it there. Yeah. Anyway. Not C++ again? No, it's too late. Alright. See you guys next time, bye.